We continue solving neetcode and let's. All right, so let's go. So it's easy task, so we should go quite fast here. So we're given an integer array nums and integer k. We return true if there are two distinct indexes I and j in the array such that num I equals to num j and abs I minus j is less than k. All right. So, for example, we have. All right. So let me try to understand first the question. So we are given an array of nums, and also we have some k that is integer k, and our task is to return true or false if we have nums I equal to nums j, where I minus j is less or equal to k. All right, so let's do something like this. So we have like this, and then we have k equal to 3, and here we have 1, 0, 2, 3, and like 3 minus 2 is equal to 1, 3 minus 1 equal to 2, but so here we can actually take anything, and we see that we have two equal values here, so it's true. Also, if we don't have equal values, it would be false here. And what does it mean? It means that we also have some so it's test cases. Let's check constraints. So can I say that array length is from 2? Because if it's 1, it would be also always false. And 5. Yeah, so if it's 5, we cannot use two loops here. And we see that we have negative values. Yeah, it doesn't matter. And we have some k. All right, so what we can do here, we can try to use a sliding window. And with this sliding window, for example, we have 3. So we take 0, 1, 2, and then 3. So actually it's 4 values. And then we move and when we see a duplicate, we actually return false or return true. If we don't have duplicates, yeah, so we have just sliding window and we go forward. So for this we need a set of integers, new hash set, then we have integer j, it would be that would be 0. Then we have integer I, and I is going yeah, so first we should go one time till so we have another I that it would be 0, and here we iterate one time y is less than k, I plus plus equal also to k, and if nums I, if set contains nums I, we just simply return true. And we can do like this. So if we add and we don't have anything, it would be false. But if we add, we have anything, it would be true, and we return true. So now I is equal to k. So I is here. What we need to do here is iterate from k. So I think we don't need this I here. So now we iterate from k to k is less than nums length I plus plus, and at the end we just return false, or sorry, true, or false, because we don't have, yeah. And here what we do, so when we on k, we can do like this. So k plus 1, we should do set remove set remove I minus k minus 1 and so it would be nums okay, and here I should do like this, the same, but we add k and we return false. So yeah, so we have this one and this one, and let's try to run. 0, 1, 2. Then we move. But here we have, no. We move and we move. So how we have true here? How we can get true here? If we go 0, 1, and 2, we put everything here. So output would be here false. And yeah, let's what we do. Let's print our set here, and let's print it here as well. All right. So we are getting somehow here okay, maybe we should add here something. Okay, so yeah, at least, yeah, so when we add, probably it's true, but when we add, yeah, it's false. Okay, so now it's correct. So we add 0, 1. Yeah, so we can remove this one. Yeah, so here we have 1, 2, 3. And then we should have the same logic here. Let's run. And let's have it like remove. We can print it when we remove and when we add. Yeah, so we see that we remove correct, and now car is 2, 0, 1, 2, right? And now we should add this one. So our set, when we add element 1, we should actually add this. Yeah, because here we remove 2, 3. And we should add I. Yes. And here I. Yes. And now let's remove this. And let's run. Okay. Okay, we have k equal to 1. Okay. Yeah, if it's 1, we can just, I believe, just check if nums length equal to 1, we just return false. And that's it. Okay. Let's take like mass min between k and nums length -1. Okay, we're done. I believe this one also can be done. Yeah, so we see that we actually even beat the solutions. Yeah, we also have hash set. Let's check our last submission. Yeah, we have some map. Why do we need map? I don't understand actually. Why do we need map here? But yeah, actually we're done. It's quite good. Yeah, it's a good question, I believe. It's a good question. Contains duplicate too. So we can mark it as done. Let's go to the next one. It's also easy question, so I hope that we will done it. So best time to buy and sell stocks. So we are given an array of prices and the price of given stock on each day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. Return the maximum profit you can achieve from this transaction. You cannot achieve any profit. If you cannot achieve any profit, just return 0. So here we have like 7, 1, and then 5, then 3, and 6, and 4. So output will be 5, because for example we can buy with 1 and sell with 6, right? Okay. How we actually can do this? So when we have on 7 and next value is less, we didn't buy here. When we have next value is greater, we can buy on 1. Mhm. But how to find actually this value? How to find that we can, yes, so we have also quite high constraints here to 10 and 5 power, but we need to find the next position. So so to find the next position, we can do like find 5, right? So we found a 5, and we calculate like 5 minus 1, it would be 4. But it's not the greatest profit that we can have. Um, mhm. So we only should buy when we have next value is greater. So we have 1, 5, and then 3, 6. But how we can find this 1, 6? So sequence here is quite important. So we need to figure out the maximum value from 4. So we can take 4, 6, then 3, 6, 6, 6, and 7. So it would be the maximum value from right to left, and then the minimum value from left to right. And then I think we can find this solution. So first we create an array from minimal values and then from maximum values. So what I mean, so for example, it's quite strange probably example, but we have this array here, and then we go from left to right and we find the minimum, and then we go from right to left and we find the maximum. And then for each position, so then for each position, what we can do, we can take the current, right, and find the right. So for example, we take 7 and we know that on the right the maximum would be 6. So we should it would be just 0. Then we have 1 and we know that the maximum, so actually I think we don't even need this minimum, so we just need maximum. So I know that I can buy with 1 and my maximum here is 6, then for 5 and so on. So I actually just need this to create my maximum array here. So let's do it. So I have maximum array, the same length, and then I just iterate from array length minus 1, 1 is greater than or equal to 0, and I minus minus, and I'm just populate on I there. So I start with, I think with 2, and I have some maximum, max value, and max value would be max array length minus 1, because I didn't change it anyway. And then here I just do max of max value, and so actually I don't need, I think, max value. So here I just take max I and max I plus 1. And here I actually populate my max array. And then I just iterate one more time, now from 0 to array length minus 1, I plus plus, and here it will be my result is 0. Then I need to return this result. And here what I do, I just take the next element. So I should iterate minus 2. So here I check if array I plus 1 is less than, no, I check my array I, and here I check max I plus 1. If this one is greater, then I do nothing. But if this the case, right, then I do like this, mass maximum between result and max I plus 1 minus array I. Yeah, should be something like this. Let's check. All right, so here I have 0. Why? I have 0. Okay, let's first verify how we populate our max. Yeah, white zeros. Okay, max I. Yeah, so I still need to have, yeah, so here should be array and not max. So what? Yeah, so I have here here I should populate max array length -1 equal to array the same. I still need to populate it. Yeah, so it will be 4, then 6, then 6. But why I have here 5? Because it still should be 6. But now I have 5. Strange. Strange. Let's check. Okay. Yeah, so I think that I need to do like this. Yeah. And now submit. Okay, run answer. So let's use this as an example. So I have prices 1 and 2. And my result should be 1. So here I start with max 2. And then I go 1. So yeah, so here it should be 2 and 2, right? So it's correct. But then I start, yeah, I think I should start this one. Yeah, now submit. Yeah, so it's done. Let's run it. Okay, so we're here. Let's verify what we have from the previous run. Yeah, so for previous run, it's better. No, is it better? It's the same, actually, logic. The same milliseconds. So we have profit. We have buy price. And then we start from 1. And if buy is greater than price, we update our buy. And then, yeah, update profit and return profit. Do we have another one? Mean. If mean is greater, then we update our mean. Okay, if not, okay. So we just, yeah, so we just collect this mean and if mean we update, otherwise we just remove. Yeah, this, I think this is more logical to implement this way with just one loop. I think our logic more complex. Yeah, so I see that I never actually solve it this way. So every my previous solve was actually the same. So now I have like super unique solution. But how the others solve it? Yeah, we see that other actually solve the same way. And here, yeah, it's a very strange thing. But here, yes, we have max profit. We update our mean, and yeah, update our profit as well. It's interesting, like, do I solve same with sliding window? No. Have editor? No. Solutions. Solutions. Mean or price solution. Cadence algorithm. What do we have in cadence algorithm? Ah, yeah, that's probably cadence algorithm. All right. Yeah, here we don't have space actually, so our logic is bad because here we add another space and here we don't use any space, so we see that memory here, yeah, is the creators from here. Here I don't understand why we use so much. But yeah, nevertheless, we solve our task, and that's all for today. See you tomorrow.